This is an introductory 3D Studio Max tutorial on the very basics of editable mesh modeling. We're going to start by hitting Alt-W for a single screen and bring in some primitives. Here is a box, a cylinder, and a sphere. Now, whenever we are doing editable mesh modeling, we are working with a process similar to molding clay. Our primary tools are cutting and extruding a process of pulling out geometry. If we hit F4, we can see the wires on our various objects. These are still primitives. They're not yet editable mesh. If we go to the Modify panel, we can still see the parametric controls for changing different functions of the surface. For example, we can increase the steps on the surface, the tessellation, the divisions on the surface, the tessellation, so that now this box has 3 divisions on each side. If I were to set the length, width, and height to the same number, we essentially get a Rubik's Cube. The sphere, we can increase the segments to increase the smoothness of the curve. Same thing with the sides on the cylinder. And we can add segments to the top. But to truly manipulate these in a very detailed way to create any kind of form we want, we need to convert them to an editable format. And the editable format we're doing today is editable mesh. If I right-click and convert, for example, on this box, I can convert to editable mesh. And I lose all of my basic parameters, and instead I have vertex, edge, what 3D Studio Max calls face, polygon, and element. In truth, 3D Studio Max reverses face and polygon. A polygon in the 3D industry is a triangle, a single poly, which is how we count the volume of a model, that is how we count the weight of a model. When we talk about a low polygon model, we're talking about the triangles. A face is anything bounded by white lines. Right now we have 4 sides, but we could have many more depending on what lines we erased. So really, this should be called polygon, and this should be called face, but 3D Studio Max reversed this long ago and appears to have kept it that way. Now that we have this converted to editable mesh, we no longer have the ability to change the size just by typing in a number. And if we want to change something, we have to select these sub-object modes. We're going to focus on the vertex, edge, and what they call polygon mode, which can be accessed here under selection, or by opening up editable mesh, we have vertex, edge, and polygon. And it can be sometimes easier to access it here in this list because as we go down this roll down to look at other functions, these selection tools are always available. We could also click on the keyboard. Numbers 1 is vertex, number 2 is edge, and number 4 is polygon. With any of those selected, for example vertex, we can move, rotate, and scale. In other words, transform our object. We can select a whole bunch of vertices or just one, and we can move them. We could select more than one, and we can rotate between the center of them, and we can scale the distance between at least 2 vertices. Same thing with 1 or more edges, of course holding down Control to add to my selection, or holding down Alt to deselect. And selecting 1 or more polygons, I can scale, rotate, move. Move, rotate, scale, of course, are up here. Move, rotate, scale. I also have W for move, E for rotate, R for scale. And that is the basic transforms that we can do to make any shape that we want. If we hit F for front, for example, I'm going to hit Control Z to undo some of the changes I made before. I could begin to get a more curved shape by selecting around these vertices and these and through careful manipulation could get a curve on one side of this form. But a lot more excitement happens when we actually cut new lines into the form and pull out new geometry. And that can be done primarily under the polygon toolset. Each of these different selection modes, we call them sub-object modes, the vertex sub-object mode, the edge sub-object mode, the polygon sub-object mode. Each of these sub-object modes have different buttons that become visible and available to us. For example, right now the weld tools are grayed out because we're in the polygon mode and not the vertex mode. But we do have under polygon an extrude function. We can select one or more and we can click left mouse drag up or down. Down would cause an extrude inward, up cause an extrude outward. We could also simply click and drag these arrows. Do not click on the arrows multiple times. That will cause multiple extrudes that would have to be removed and welded later. There's also bevel, which is a combination of extrude with a scale that insets the scale evenly in all directions. If I were to use basic extrude, and then just use an ordinary scale by hitting the R key, notice that it doesn't do an even inset on all sides. This side has a much smaller inset. This side has a bigger one. Whereas if I use bevel, with its inbuilt scale system, I get an even inset on all sides. So that's how I pull out new geometry. In order to create new geometry, I can use the cut tool. The editable mesh cut tool is more limited than the more advanced editable poly cut tool that we'll see in next week's lesson. In editable mesh, we can only cut between existing edges. Right-click to end the cut. Now, if I want, for example, to create a shape inside of this shape, one way to do that would be to cut across the form, cut, and then to cut inside those existing lines. And I can, in this case, for example, get a 8-sided shape. You will notice that there is some brokenness to this shape. This is a good time in the Vertex of Object tool to take a look at our welding tools. If cut and extrude or bevel are to create new geometry, weld is to reduce geometry, to optimize it, to remove any waste or any pieces that we don't want. Under weld, target is the one that allows us to remove individual vertices. We can select this vertex and move not the vertex but the mouse to a destination vertex. Notice that right now the mouse is a black cross with 4 arrows. If I hover it over another vertex, it changes to a cross with no arrows. When I release, the vertex snaps. So we don't care where the vertex goes in that process until we release. We only care where the mouse goes, and then the vertex will snap. And in this way, I can remove all the extra vertices. Select this vertex, and I can target weld all of these extra vertices that got wasted. The editable mesh toolset, even though it has some limitations, is enormously robust. These tools always work. They do not break. And so even though I primarily work in editable poly when I'm doing polygonal modeling, both editable mesh and editable poly are called polygonal modeling, moving polygons. Even though I primarily work in editable poly, and editable poly is much, much faster, it's really a good thing to learn editable mesh because you can convert back and forth between them, and once in a while when editable poly breaks, I can convert to editable mesh, fix the mistake, and then go back into editable poly. Now that I have this shape, I can go back to the polygon subobject mode here in editable mesh, and I can extrude out this new shape. I can scale it. I can extrude again. And this is the basic mode of editable mesh modeling. It's all about working with the combination of these tools to create the form you want, mostly with cutting and extruding. So what I'm now going to do is I'm going to cut and extrude an arm out of this space. We already have a somewhat circular form. I can apply a modifier here in the modifier list called spherify, and that will get me more of a circular form. I can then right-click once again to convert to editable mesh to bake this spherify down into the mesh. And that gives me, once again, an editable mesh to work with, but now more of a sphere, more of a circle rather. And now I can extrude this and scale and extrude again, and I essentially have a shoulder. Now I can extrude again, scale, extrude again, and I have a low poly bicep. I can extrude again, scale up a little bit, and rotate. Of course, I'm hitting WER to move between move, rotate, and scale. Extrude again, shrink, rotate, move. Now I have an elbow, extrude again, scale, extrude again, and scale down. And I have my lower arm. And now I can extrude, scale, and also non-uniform scale by selecting the z-axis, the blue z-axis, and dragging down on only that axis. Non-uniform scaling here in these sub-object modes, whether it's vertex, edge, or a polygon, is a really good practice. We try to avoid non-uniform scaling on the object mode. We would not want to just do this on the entire object, because if we right-click on the scale tool, we can see that it creates a non-uniform scale in the X form. The X form is this white box selecting the object, and a non-uniform scale there will have a negative effect on any modifier that we put on the object. It also creates problems in rigging when it comes to animation. So it's better to leave this at a uniform size, and when we convert this to something editable, like editable mesh, we can select all the vertices and non-uniform scale them here. And by scaling in the sub-object mode, if we right-click on the scale tool to see its properties, notice that the X form is still 100, 100, 100, which is what we want. Going back to our arm, I'm going to, having extruded out a wrist, I'm going to extrude out a palm. Again, non-uniform scale here in the sub-object mode a little bit more. And this way. Move it aside a little bit and rotate. Here we have a space from which we'll extrude the thumb. And now I'll extrude again. And again go a little bit thinner. I think I want to pull this out a tiny bit more. And this is the form from which I will cut and extrude my fingers. So let's start with a thumb. I'll select this area here. I'll do a very, very small extrude that I really just want to use for shrinking. And pulling out a little bit. I don't want the thumb to come straight out of the side. I want it to come a bit more from the side and the bottom. So I'll move this down. Move this in a little bit. And this will be a good form from which I will extrude the thumb. And I'm going to use bevel, so I can have a combination of extrude and scale. I want my thumb to come straight out. That is my preferred mode for rigging. I'm going to non-uniform scale here on the x-axis, which is the axis that's perpendicular to the flat shape that I'm trying to create. I think I'll scale that a little bit smaller. And then extrude out, scale bigger, pull it out a little bit, bevel out, scale in, and rotate. And here I have a decent start on a thumb. To cut the fingers, I will go back to the cut tool, draw a line to bisect each of these sides. So I now have 1, 2, 3, 4 spaces. But I'd also like to have a space between the fingers. I'm going to extrude the fingers out of the space, but I want a space between. And certainly I could cut additional lines, but under the editable mesh edge subobject mode, there's a tool called chamfer that allows me to take a single line and split it into two. Often this is used on the edges of large objects like furniture. I'll go to this edge right here to create a curve. When you're creating furniture, a very, very sharp edge like this feels artificial, feels like you could cut your finger on it, and so we use a chamfer. At the very least, one small chamfer will help that edge not feel quite so sharp, but if you do multiple chamfers, you can get a really nice, smooth surface. You want to be careful to not allow subsequent chamfers to cross over each other, or you'll get bad geometry, what we call interior geometry, non-manifold geometry, broken geometry. You want to be careful to avoid. Oops. Notice that every single quad is actually two triangles, and using the subobject edge mode, you can select around an area and see the invisible line that bisects it. This line does exist, but most 3D functions work better if you're working in quads. This right here is much more than a four-sided shape. We have 1, 2, 3, 4 sides, but then we have 1, 2, 3, 4, 5, 6, many, many sides. If I select around this geometry, I can see these invisible edges, and in the sub-object edge mode, there's a turn function that allows me to decide, well, actually I want this edge to go the other direction. Typically, you want the edge to go in the shortest possible direction. Here it's longer than it would be if I turned it, and you want to leave it in the shorter direction for light to move over the surface better, for deformation to work better in something animated. We also want to have primarily quads. So I can select this edge, for example, and the edge sub-object mode toolset, go down to surface properties and choose visible. And now I have 1, 2, 3, 4 sides to this polygon. I can select around, choose this line and hit visible. And again, I have 1, 2, 3, 4 sides. And now I would choose this line and this line to make it visible. And it's true that while I have a quad here and a quad here, I only have a triangle here. And a triangle is not ideal, but it's better than having something more than 4 sides. Frequently, rather than having these lines be so long, we'd rather they be short, as mentioned earlier. If I make all of these invisible, being careful not to select anything in the back, I can turn them so they run across this edge. Turn, 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 turn. And now I can select this line, go down to Surface Properties, make it visible, and this line to make visible. I have a triangle here, I've got a quad here. I can make this line visible for a quad, and this one visible to make two quads. And that is using those edges optimally, shortest possible distance. Light will move over that surface in the best possible way. So going back to our hand, now that we've explored a few of the edge tools, F4 so we can see our lines, I'm going to move these edges over to get the proper proportions for each finger. The pinky gets the smallest space. The middle finger will get the biggest space. And I also want to select these vertices on the side of the pinky and move them back. From the top view, the space that the fingers are extruded from should be curved. The pinky originates further back than the fingers that come after. They come out at angles, and so this curve helps to create those angles. Notice that I'm doing a lot of movement in the XY plane. I find that to be the most convenient plane for most of the work that I do, especially if I'm working in a top or a bottom view. So now that I've made a few cleanup adjustments, if I select edges, I can work a little bit faster than if I'm in vertices if I want to select entire lines. So now I can select these three lines and I can chamfer them to create the space between the fingers. And now I can select each of the fingers. I'm going to non-uniform scale them to make them more square. I'm going to take a moment to scale up these edges. Remember that if you keep hitting the scale tool, you will change. If you keep hitting the letter R, you'll change which scale mode we're in. We always want to be in the first one. Always, always, always. It's a square with a single diagonal arrow. That way we get a uniform scale when we want it. And we can always have non-uniform scale by scaling on one of the axes. But this way we actually have the option for a uniform scale. And now I can extrude each of these fingers. I'm going to use the bevel extrude type. So these come out, come in a little bit, and then we can make a knuckle, bevel and scale, come out, come in a little bit, and another knuckle. And each of these now need to be rotated. I want to rotate them on their local axis, so they each rotate in their own direction. Just like with the thumb, we want them pointed downward. And now in the top view, we can select rows of vertices in order to adjust our form. I can make this pinky a little bit thicker, and I can move its vertices inward so it has more of the proportions of a pinky. I'm going to leave the middle finger at its length, but I'm going to adjust the others. I would like to move each of these knuckles back a little bit. These as well. And now I'm going to select the middle of each of these, the middle edge of each knuckle, and pull that up. And certainly there's plenty of cleanup work to do, but that is essentially what I'm looking for. I can use target welds to weld this vertex back. I can use the cut tool under the polygon subobject mode to both draw tendons and to get quads. Notice how having good geometry, good surface topology goes hand in hand with creating forms that make sense for, in this case, the body that we're trying to make. Reduce the puffiness. And now, to make this slightly less chunky, I can go to the polygon subobject mode, select around all of the polygons of the arm, and go down to the surface properties of polygon. Remember that under edge, surface properties gave us access to visibility. But under polygon, surface properties give us access to material ID and to smoothing groups. In smoothing groups, what we're paying attention to right now is the faceted nature of this geometry. F2 lets us turn off and on the highlighting on a surface. Right now, if we hit F4 to not see the lines, we can see this is very faceted, as if it were cut from crystal. Selecting all of those faces again, I can hit Clear All and give them a smoothing. The numbers don't matter. A 11 is not more smooth than a 10. What matters is when you want a hard edge, for example, this hand being a hard edge against the surface of the block, they just need to have different numbers. So if I select on the block, this has a number 6. If I select the entire arm, I can give it, let's say, a 1. And now the arm looks very smooth, and it has a very hard edge where it emerges from the block. If I want to make this arm be higher poly, more detailed, I can cut in additional lines. One way to do that is to select these faces and use the slice plane function. Slice plane, which by default is going to come out as a horizontal plane. So I can go to the rotate tool and then right click on the rotate tool or hit F12 to bring in the transforms. And I can rotate 90 degrees on X. I want to rotate this way. 90 degrees on the X offset. And then I can bring this line over. And in the top view, I can angle it to get the actual line that I want. And even though I can't see, except in the top view, where the line's going to go, I can now hit Slice, turn off Slice Plane, and a new edge has been created. And this edge, if I select the vertices, can be scaled to create more of a curved shape. And I could do that multiple times. Notice that the Slice Plane tool in Editable Mesh not only cuts the visible edges, it also slices through the invisible edges. And this would require now a lot of target welding to clean up. Life is easier when it comes to Slice Plane if this is done in the Editable Poly toolset instead of Editable Mesh. So we're going to right-click, convert briefly to Editable Poly. Select those faces again, and go find the Editable Poly Slice Plane. Once again, we're going to have to rotate it in position. So I did an offset rotate on the x-axis of 90 degrees, and then I'm moving into place and rotating it. And we can already see some of the advantages of the editable poly toolset. One is that we can see the line that's going to be cut before we cut it. I'll do a slice here, I'll do another slice here, and then right-click and convert back to editable mesh. And now I can select these vertices, I can scale them to get a nice curve, and notice that there are no extra vertices being created. The editable poly toolset treats the invisible edges as if they were in a state of flux, and so a slice plane cuts through the polygons, and the program automatically turns the edges to where they need to go so they aren't recut. Here in editable mesh, I can see the invisible edges, and they've been reconfigured nicely. So when you want to use slice plane, I don't recommend using editable mesh. I would use editable poly for slice plane. The other function that we're going to use editable poly for this week is filling in a hole. If I were to, for example, delete these two polygons, in editable mesh, I have a couple of options for filling them in again. One is I could select these edges and shift-click drag out the side. This creates new geometry, and now I can use target welds to fill in the gap. That's one way to do it in editable mesh. Another, if these were deleted, is to go to the Polygon Create tool and to click in a counterclockwise direction around each vertex, going all the way around the mulberry bush, and that creates geometry. If the geometry is facing away from us, right now it's facing toward us, but if it were accidentally created going clockwise, then it may look like the geometry is there and fine, but if we hit Shift-Q for a quick render, we can see that it looks like there's a hole. That's because those normals are facing the wrong way. And so I can find the flip function, which is here under Surface Properties above Smoothing Groups. I can go to Flip and then hit Shift-Q, and I can see the surface. So that's how we would do it in editable mesh, but this function is much easier in editable poly. I can, if I have a hole, I can convert this to editable poly, go to the sub-object border mode, a function that's not available in editable mesh. I can click the border and I can hit cap, and that instantly gives us that space filled in. And then I can go to edges, select around. I'm going to hit G to turn off the grid. I can select the edge that I want to run down the center. In the edge mode, I hit turn, and then I hit visible. And now that's repaired. Now let us look at a few more vertex tools. If we go to the sub-object vertex mode, we've already seen target welds, where we can click on a vertex, click on the target button, and move the mouse, the cursor, not the vertex. The vertex, we don't care where it goes. We move the mouse over the destination vertex that we choose so that it becomes a cross instead of a cross of 4 arrows. Release, and it will snap, and that reduces the amount of vertices. We want to always, when we're polishing up a model, we want to pay attention to where there might be some vertices left over on any straight lines. If we hit F4, we can see that these vertices are not contributing to the overall form. In order to contribute, they would need to be moved. They would need to be part of a curve. Since these vertices are not part of a curve, we want to remove them. One way to do that is target welds. Another way to, for example, remove these vertices is a button called collapse. Here is collapse. With multiple vertices selected, I can hit the collapse tool, and they all become a single vertex, and then this single vertex can be target welded to one of the sides. Collapse works in other modes. I can go to Polygon and collapse. A common tool, a way of getting rid of a whole bunch of lines. Let's say, for example, I did not want this entire row of lines. So I have those edges. I can hit collapse on all of those edges and make that side shorter. The other tool that we have is weld selected. Weld selected is like collapse, except it has a threshold. Right now the threshold is set to 0.1, which would mean that the vertices would have to be directly on top of each other to collapse with each other. If I hit selected, we get an error message. No vertices within weld thresholds. But if I increase this to a large number, let's say 10 generic max units, and hit selected, these will collapse into each other. If I make this a much smaller number, perhaps only 2, then only the neighbors are going to collapse into each other. This threshold number represents an invisible threshold bubble around each vertex, and only other selected vertices within that bubble get collapsed. Now let us say that we were trying to make a person, albeit a very boxy one. I'm going to delete this side. And now I'm going to get out of the subobject mode. You can do that by clicking on what was selected, but the most surefire way of getting out of the subobject mode, if you're in one, is to just go back to the Create panel. That gets us out of subobject mode. There's no question we're no longer in vertex, edge, or polygon. And now I'm going to go up here and hit the Mirror tool. I want to mirror on the y-axis in order to get two sides, and I'm going to create an instance first just to see it. If I move this over, I now have instance copies, which means if I select, for example, these vertices up here and drag them up, the other side does the same. And so for character modeling, this can be very, very convenient. I'm going to move them very close together, and I want to attach them. But if I hit the attach button, you will notice that it does not let me attach the other, and that's because they're instances of each other. And we know they're instances because they're bold-faced here in their names. But if I select either one, right-click and convert to editable mesh, the converting breaks the instance, and now I can select one of these and attach the other. And now we see the true power of the Weld Selected tool. I'm going to select all of these vertices, and going to Weld Selected at a very, very small number, maybe only 0.5, I hit Selected, and they weld with their neighbor exactly as I would want without having to collapse each individual pair. Now let's take a look at a few more tools that could be used for a variety of purposes. In this case, we'll use them to make an openable door. We'll start by going to the Create panel to create a box. That's going to be a door in the chest of our person. Why not? I'm going to hit Alt-W to get multiple views. And I'm going to choose the left view, hit F3 to see surface. I want the right view, so V for multiple views. That's the letter V on the keyboard. And then R for right. Normally R is the scale tool. G to turn off the grid. F3, I can see my object. Okay, and this is going to be the door. So I'm going to start by converting it to editable mesh. And earlier, I showed you how to use the cut tool in combination with the spherify modifier to create something like a circle for extruding the handle. Here is another technique for doing that. I'm going to start with a polygon, do the tiniest bit of extrude. I'm actually just going to tap this button once for a 0.1 extrude. So it's barely sticking out at all. And then I will scale it. This tiny, tiny little extrude, only a slight distance coming out. I'm going to move it over. And I'm going to drag this edge down until I have something pretty close to a square. Now I want a circular shape for extruding out the handle. So a good way to do that when you're working with editable mesh is to select these vertices and then apply the chamfer tool. And by chamfering these vertices, I've now gone from a 4-sided shape to an 8-sided shape. I can deselect these extra vertices here, chamfer again, and I go from an 8-sided shape to a 16-sided shape. And this can now be extruded to make my handle. I'll extrude out, scale in, bevel out a few times, and I've got my rounded handle. I think I would like to move these vertices out, so I'll move them here on the x-axis, a longer handle. And also, I would like to select all of these and give them a different smoothing group from the surface from which they were extruded. I think I'll let the ball also have a different one, so I get 2 edges, an edge here and an edge here. And there I have a rather pronounced handle sticking out of that door. A couple more things to note. If I want to select the vertices that are facing me, but not the vertices that are facing the opposite direction, for example from the side, right now if I select around, I get both one side and the other. But the very top of the roll down, just under the selection tools, we have ignore backfacing. If we turn this on, then if I select around these vertices, I only select the side that was facing me. If I go to the right view, so I'm looking straight at this knob, and select around, I do get these vertices here because they're considered to be facing me, but not these vertices here. The blue ones are not selected, the red ones are selected. That is ignore backfacing. Turning that off, let's say we want this door to be able to open. If I right now hit the letter E for the rotate tool and rotate, it's rotating from the middle, which is not a very satisfying door rotation. We really want it to rotate from the side as if it were on a hinge. So I will go from the Modify panel over to the Hierarchy panel, click on Effect Pivot Only, and I can then drag the pivot over. And with that over, I turn off Effect Pivot Only, or just go to the Modify panel, or the Create panel, hit E for rotation, and I can get a much more satisfying door opener. A tool that I don't tend to use very often, but some artists tend to like, is the Soft Selection tool set. If I, for example, click on just this vertex and drag up, well, only that one vertex moves up and creates a very sharp point. But if I scroll down to Soft Selection and turn it on, I get a threshold around the fall off. The fall off is our threshold, deciding how much of the area around it should be selected. Right now it's at 20, and if I drag up, that point I had selected moves up fully, and with the change of the color we get less and less selection, but we get a much softer selection. If we increase the fall off, then much more will come with. If we decrease the fall off, let's say to only 5, well then only that one area moves a little bit with it. And there are different types of fall off. I could increase pinch, so that even with quite a large number in my fall off, I'm going to get a very different result. I could also increase bubble, which moves the fall off to a lower edge. And this can be used for making a cushion a little bit softer, but generally I would be careful about using this tool. It can tend to create pretty uncontrolled geometry. Those are the major tools that we're going to talk about today when it comes to working with editable mesh. And the next thing we're going to do is see an example furniture project